Good morning.
Good morning,
Good
sir.
morning, sir.
Good morning, sir.
Good morning. So, in today's class, we'd like to start that stepper motor already I have started. I would like to finish the stepper motor, and afterwards servo motor. That is the last point in the fifth unit, A chapter. So, what I have decided to finish your DCMT syllabus tomorrow. So today two classes, and by tomorrow two classes, I will finish your DCMT. Where I have stopped this particular chapter, what all things I have covered, do you remember? What all things I have covered in the last class? Do you remember those things? Can you tell me?
Stepper motors.
That is correct. That is stepper motor only. Stepper motor, what all things I have covered? Can you tell me? Yeah, I'm asking you people only. Those who have attended. So I guess you 20 people have attended the last class, except some diploma students. So in stepper motor, what all things I have covered? What all things you know about stepper motor now? Based on that, I will start now next concept.
Types of stepper motor
Then,
and variable reluctance stepper motor.
okay. In that variable reluctance stepper motor, what I have explained there actually.
Electromagnetic torque and reluctance torque.
Very good. So electromagnetic torque and that reluctance torque. You got the difference, right?
Yes.
What is the difference between reluctance torque and electromagnetic torque? Correct?
Yes, sir.
Correct now? So now let me explain that variable reluctance torque. That variable reluctance torque already done it. So those are attending first class, just go through this basics. So I have started stepper motor here in the last class. So in that stepper motor definitions I have covered. What is that stepper motor? Stepper motor is nothing but it is a special type of motor which converts which converts which converts digital pulses into incremental steps, incremental rotations or incremental rotations. Or the stepper motor is a special type of motor which rotates in steps, The next thing is what we have seen. Its types we have seen, and in the types, and before going types, let us go through that. Every motor consists of the construction part. So if you go through the construction part, basically this stepper motor has two parts. One is a stator, and another one is a rotor. Now, based on the rotor design, it will be classified. So classification or types based on the rotor, it is classified as permanent magnet stepper motor and variable reluctance, variable reluctance stepper motor. Then third one is hybrid stepper motor. Hybrid stepper motor. So these are the types available based on the rotor design, based on the rotor design or rotor construction. Now in that, for your syllabus, variable reluctance stepper motor is there. So for that, what all things I have explained is, usually there are two types of torques are available. Torques. One is reluctance torque and another one is electromagnetic torque. Electromagnetic torque. So two types of torque available always. So one is electromagnetic torque and another one is reluctance torque. What is reluctance torque and what is electromagnetic torque, I have explained in the last class. Once if you understand what is reluctance torque, then easily you can understand what is variable reluctance stepper motor. That is what I have explained this reluctance torque. Now let me move to this particular motor, that is variable reluctance stepper motor, because in your syllabus that particular motor they had mentioned. So this one, variable reluctance stepper motor. In short, it is called VR type. In short, it is called VR type. So variable reluctance stepper motor, from the point of construction, if we start, basically it consists of two parts. One is a stator, and stator is a stationary part, which is the stationary part which is not rotating, and rotor is a rotating part. Rotor is a rotating part. Now this stator is stationary part which is made up of electromagnet, and rotating part which is made up of soft steel will be used. Soft steel will be used, or iron bar will be used. This is nothing but a rotor here. Though, so this is a construction point of view. Now, if you check the diagram, how it looks, stepper motor. So I can show you in rough diagram. So this is the stepper motor stator, if you can consider here. Just for my reference, I'm drawing some lines here. That's it. Now, what happened? Here we get one pole. Here also we get one pole. Sorry, it's not working. Pad is not working. Just wait for a second. Okay. So let me start with the beginning. VR type stepper motor. So construction we already see, means the told construction. It is a stator. It consists of stator and it consists of rotor also. Stator is stationary part, and it is made up of electromagnet, and rotor is a rotating part, and which is made up of soft steel. Then from the point of a diagram, let me show you the diagram, so how it will be. Some reference lines I'm drawing here. Something problem with this journal only today. Okay, let it be. We'll try once again. So some references lines I'm drawing just for my drawing purpose. That's it. You don't worry about that. There is one pole, here another pole, here one more pole, here another pole, and again here one more pole, and here one more pole. And then you can go on joining these things in this way. So what happens now? These are nothing but, this is the stator frame, and now this is stator poles, and on the stator poles their winding will be wound. In this way, winding will be wound. That winding will be wound here, and now rotor poles will be in this way. So this is nothing but rotor. Here shaft will be there in this way, shaft as well as rotor. But this rotor does not consist any winding. It is made up of soft steel. The rotor is made up of just a soft steel, and it does not have any winding on it. Here stator poles are there, and on that windings are there, and these windings, because of that, it is called electromagnet. It is called electromagnet because you are going to give the supply from this one wire, from this one wire, from this one more wire, from this one more wire, from this one more wire. So these will be connected in somewhere in some series fashion or in parallel fashion. It will be connected and it will be given to the supply. So here supply, maybe DC type of supply will be given, and that supply will be given to this with some arrangement. So ultimately what happens, this also carries current, 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 this also carries current. And accordingly what happens, these electromagnet gets energized. That means magnetization will be produced. When magnetization gets produced, this rotor, what happens here, if it is produces N, and definitely this, consider that this is a phase, this is B phase, and this one is C phase, this is A dash phase, this is B dash phase, and this is C dash phase. Now if A phase, if you energize it now, so for example this will become energized and it becomes N pole, and this becomes S pole. So flux starts flowing through this to this, hence it energizes. Now after some time B gets energized, and when B gets energized, this will become de-energized. When this gets de-energized, so this becomes N and this becomes S, and now it will flow from this, so it will get attracted and it starts moving this side, then it starts moving this side, so C gets energized, then again this rotation goes on continuous. So this particular rotor goes on, rotates in stepwise. So here what we are going to get, if you energize A and A dash phase at a time, then 30 degree of steps angle you are going to get. So 30 degree it moves in this way, 30 degree, and again B, if you energize, then again 30 degree it will move. So in that way it moves in the 30 degree fashion. So it is called, it is moving in the steps wise. Otherwise if you want to make it to 30 degree instead of 30 degree, if you want to make it rotate at 15 degree, then some arrangement we need to do. A and B at a time we have to energize, that time it will rotate 15 degree. Then afterwards we have to de-energize the A, then we have to energize the BC, then afterwards we have to CA. In that time we what we will get 15 degree of step size we are going to get. In this way rotor starts rotating in the steps due to reluctance torque. Due to the because of reluctance torque, there is no electromagnetic torque, because electromagnetic torque will produce only when there is an uh, uh, a flux, interaction of flux from both the side. But here flux is there from only stator side, there is rotor, there is no flux, only it is producing because of low reluctance. Due to that low reluctance, this rotor getting attracted or repelled, and it started moving. And that is what the principle used here in the variable reluctance type stepper motor. This is the basic operation of variable reluctance type stepper motor. But basically we use hybrid stepper motor in our works. We use hybrid stepper motor. Here for your syllabus only variable reluctance type stepper motor is available, but practically this hybrid stepper motor will be used most of the time. And this hybrid stepper motor, construction wise, what it is, the rotor which is made up of both permanent magnet also, and it is covered with a soft steel at the outer side. Hence, it is a hybrid stepper motor, what we used to call. That is the difference. And this hybrid stepper motor, instead of like this, it will be having a teeth. For example, this is the rotor. So rotor will be having teeth like this. Sorry, stator will be having a teeth like this in on the pole. This type of teeth will be provided. And if you have rotor, that rotor also will be having a teeth on its outer periphery. In this outer periphery, it will be having the teeth. In that way, teeth will be there. So based on the number of teeth, so you'll come to know that how much degree it will rotate. So that is what called a step angle. Step angle means how much it rotate, how much it rotate for every pulse we apply. Every pulse we apply. So you are going to put the pulse, you are going to give the input one pulse. For that one pulse, what is the rotation degree you are going to get? That is nothing but step angle. And the step angle can be calculated is equal to ns minus nr divided by ns into nr. So ns is nothing but number of stator teeth, and nr is number of rotor teeth. Based on this, you can determine the step angle. And the step angle, what we get, least step angle is 0.72 degree we will get, and maximum, this is the least angle what we get, and maximum is 90 degree we will get. So that 90 degree means from here to here it moves at a time. So that one pulse it moves 90 degree. So that is based on the number of stator teeth and rotor teeth. At the same time, for one pulse it moves very 0.72 degree, like something like this much only it can move the rotor. So that much of precision can be obtained by using the stepper motor. Now that is what the application where we are using the stepper motor for various precise position controls, where precise position controls is required. There we can use, or precise speed control is required. There also we can use the stepper motor. That is what the advantage, and that is, these are the applications. So these applications you will get many where in the robotics you will get, at the same time the toys also you will get, in the some industries, almost packaging industries and all, there you will get. So their applications are many actually. So where precise position control is required, there we can use this. And one more special characteristic is it has very good static holding torque. It has very good static holding torque. So this is very much important. Based on this only we are going to use the stepper motor. The only disadvantage is that it doesn't have any feedback, so that the stepper motor is the uh, open loop control system. It is open loop control system. It is open loop control system. That means, for example, you are going to give the input to whom? To the driver circuit. So this driver circuit, from the driver circuit, it goes to the motor, and here you are going to get the output input, and after that input it goes to the driver circuit converts this input analog signal into digital signal, and required pulses will be generated, and these pulses will be given to the motor. As per this pulses, motor will rotate particular degree, and output you are going to get. So if you connect here feedback system this to this, sorry, if you connect feedback in this system, then it is called servo motors. Then it is called servo motor. But here feedback system will not be there. It is open loop control system. In this open loop control system only, it produces a much accuracy, much, but not exact accuracy. Sometimes it may do not work properly. That is because of feedback system. In printers also we use this particular stepper motor. So in the variety of applications we use, but it does not use the feedback system, which is advantages as well as disadvantage also, because feedback circuit makes your circuit complex and costly. At the same time, the open loop system, it makes you simple and cheap, but the accuracy, if you're comparing with the feedback system, it is less, and accuracy with the feedback system is more. So that is what a modification of this is nothing but servo motor. That will see later, but this is what about the stepper motor. Now let me show you some diagrams as well as PPTs here. A stepper motor, also known as a step motor or stepping motor, is a brushless DC electric motor that divides a full rotation into number of equal steps. That is what it is called, step motor. A standard motor will have a step angle of 1.8 degrees with 200 steps per revolution. Principle of the stepper motor. The operation of this motor works on the principle that unlike poles attract each other and like poles repels each other. When the stator windings are excited with the DC supply, it produces the magnetic flux and establishes the north and south pole. That is what I have told earlier. Now classification, if you want to see, there are types of stepper motors are available: variable reluctance stepper motor, permanent magnet stepper motor, and hybrid stepper motor. Here in general I have explained the variable reluctance stepper motor. Again, there are two types, single stack and multi stack. That is not required here. In general, variable reluctance stepper motor is explained here. And permanent magnet stepper motor, already I told what is the difference. Permanent magnet motors use a permanent magnet rotor and operate rotor, permanent magnet, and the stator electromagnet. For example, this is nothing but four poles are there. These are the stator and these are the electromagnets. And inside whatever rotor it is shown here, they have written N and S. N and S they have written means it is a permanent magnet rotor. They have used it. That is what the difference between the other motors. Now variable reluctance stepper motor is nothing but variable reluctance stepper motor have a plain iron rotor. Please note this, plain iron rotor, and operate based on the principle that minimum reluctance occurs with minimum gap. Hence the rotor points are attracted towards the stator magnet pole. So it works on the attracted. See here, that is what same thing I had drawn earlier. 1, 2, 3, 4, 5, 6, 7, 8. 8 poles are there, stator poles. Earlier I had drawn 6 actually. And here 1, 2, 3, 4, 5, 6 rotor poles are there, and earlier I had drawn 4 poles rotors. Now the stator they have shown with a pink color, blue color, yellow color, green color, like the winding they have shown. These windings they have taken outside, and this will be connected to the driver circuit. Driver circuit will be having these many wires, and those wires will be given to this, and that driver circuit will be connected to the DC supply. basically. Now as supply goes here, and based on the connection here, solid state switches will be used, like a transistor will be used, and a transistor will be switched on and switched off accordingly, so that these windings will get energized accordingly as per our logic. So when this will get energized, so this plain rotor, in this plain rotor there is no ns, there is no winding. That is what they have written, plain iron rotor or soft steel. So it will get attracted and it starts rotating, and due to what? Because of the minimum reluctance, or due to reluctance torque, it starts rotating. This is what variable reluctance motor. Then hybrid motor, what is hybrid motor? It is the combining the qualities of the variable reluctance motor and the permanent magnet motor. The hybrid motor has some of the desirable features of each. Normally, they exhibit step angle of 0.9 to 5 degrees. Then system of the stepper motor. A stepper motor system consists of three basic elements, often combined with some type of user interfaces. For example, indexers, drivers, and stepper motors. That is what I told earlier. Controllers are nothing but drivers, and before that, indexers will be used there, and that is connected to the drivers, and drivers is connected to the stepper motors. Now, this is what the system. Indexer means what? The indexer is nothing but a controller. Is a microprocessor, or it may be a PLC, or it may be a triple pi timer IC. So that which has to produce the means program should be there. So as per that signal, it sends the signal capable of the generating step pulses and direction signals for the driver circuit. In addition, the indexer is typically required to perform the many other sophisticated command functions. It gives a command function, or it produces the signals which is given to the drivers. Now drivers, the driver is nothing but amplifier. That means which increases the signal, converts the indexer command signal into the power necessary to energize the motor windings. Not all drivers are suitable to run all motors. Stepper motor is nothing but, stepper motor is an electromagnetic device that converts digital pulses. Now here whatever you are getting, it is digital pulses into mechanical shaft rotation. Advantages of stepper motor are low cost, high reliability, and high torque at low speed, and a simple motor. This is what the stepper motor. Now advantages, if you consider, it is have low cost for control achieved, high torque at startup and low speeds. It is very robust, strong, and it's simple in the construction. It can operate in the an open loop control system. This is the very important point. Then it has very low maintenance because brushes are not there, commutator is not there, so less likely to stall or slip. We will work on any environment, can be used in robotics in a wide scale, and high reliability. What are the applications? If you go through the applications, the stepper motor is used for precise positioning with a motor like hard disk drives, robotics, telescopes, and some toys. Just now I explained already. Industrial machines like stepper motors are used in automatic gauge and machine tooling, automated production equipments. Security surveillance also you can use, and medical also it can be used. This is what about the stepper motor. Now one more diagram is there, or one more. So here I would like to show some other diagram. That's it. This is the stepper motor classification: permanent magnet stepper motor, hybrid stepper motor, and variable reluctance stepper motor. There are three main types of stepper motor. So what is permanent magnet? What is variable? What is hybrid? That things you know. Operation of stepper motor also, you know that stepper motors operate differently from DC brush motor. It rotates when voltage is applied to their terminal. Stepper motors effectively have multiple toothed electromagnets arranged around a central gear-shaped piece of iron. The electromagnets are energized by an external control circuit. To make the motor shaft run, first one electromagnet is given power. That is what I have explained earlier. I would like to show some diagrams here. Not here actually, I guess in the PPT it is available. This is what here I have written: beta is equal to ns minus nr into divided by ns into nr into 360 degree. So if this beta is nothing but step angle in space degrees, how much it is rotates actually. For example, if you consider rotor teeth 3 and 6 aligned with stator teeth 1 and 5, this they have shown here. So as per this, 1, 2, 3, 4, 5, 6, 7, 8, 8 teeth are there. So ns is 8. Rotor teeth are 6. So 8 minus 6 is 2 divided by ns into nr. That means 8 into 6. 8 6 how much it is? 48. So that 2 divided by 48 into 360, so you will get the step angle. For one pulse, that much degree it will rotate. So as per your requirement, you have to change the uh, number of poles, or you have to change the what you are giving the control signal. Based on that, you can change the step angle also. So here 15 degree they have written. So will you get 15 degree? So so 2 divided by 48 into 360, so it is 15 degree. So that is what they have written here, 15 degree. So each time whenever one pulse will be given to this winding, that winding will energize and it will attract the rotor, and that rotor moves only 15 degree here. And if you want less than that, then you have to make some other arrangement, that you have to energize two coils at a time. When you make two coils at a time, that time what happens, 15 degree divided by 2, so 7.5 degree you will get. So that is called half step. This is the full step, and that half step is 7.5 degree. If you energize in that way, if you energize in the three coils at a time, then lesser than that angle also you will get. So in that way, that driver and control circuit can work in hand. So it energizes the winding, and you'll get the required degrees. See here, the variable reluctance stepper motor energizes phase C, rotor steps forward another 15 degrees. So that same thing in the another diagram they have shown. So now it has moved 30 degree, 45 degree. If you again phase away again. So here variable reluctance stepper motor, that winding they have shown, that whatever I have shown, A phase, A dash, B dash, C dash, D dash, in that circuit diagram they have shown. Here supply will be there, and supply will be given through the switches, through the control circuit, and the switch will be closed accordingly as per the which winding has to be energized and de-energizing. So based on that, that rotor will start rotating in the clockwise or anti-clockwise directions. That is what they have shown here with some other diagram. This is not required here. So this is what about the stepper motor operation. So with this, I have concluded the stepper motor explanation. And now in next class, we'll see the servo motor. So once if a servo motor completes, then a particular fifth unit, first chapter, that is A chapter, will get over. Then B chapter will be remaining. And what I have decided, that B chapter I will leave it to you. You just go through it. And if time permits, in the next February or March before your examination, I will take that chapter. Otherwise 100 marks is already covered now with the help of the servo motor. So by tomorrow I will wind up this particular DCMT subject only. So what I am leaving here, I would like to show you. See here, just go through the syllabus. See here, Unit 5, Special Electrical Machine 1, which consists of DC servo motor, plus DC motors, and permanent magnet DC motors, and stepper motor. So here today, stepper motor I have concluded, and DC servo motor also I will cover today. So that completes your Special Electrical Machine 1, which covers 20 marks. So 20 marks means total 100 marks gets over. So Special Electrical Machine 2, that I will leave it to you. If once diploma students syllabus gets over before March, then definitely I will go to this particular Special Electrical Machine 2 for diploma students as well as you people once again. And we can means we will study that. Otherwise you just go through this chapter before that if you want. Here self-learning topics for PMDC and instrument transformer, and PMDC motor already I have covered here. So instrument transformer is already given. So you can if you consider this chapter as a self-learning full. So try to study on your own. If time permits, then I will take. So for example, in the examination, you have to answer one full question. From unit 1, 40 marks will be asked, and out of 40 marks, you have to write 20 marks. So I have covered full 40 marks. So you can write anything. 20 marks will be, you can write here. Unit 2, I have covered full unit. Parallel operation of transformer and three-phase transformers I have covered. So 40 marks will be asked, but you have to write 20 marks from this. So this 20 marks is also over here. I have covered 40 and you can write 20 marks only. So 40 marks. So unit 3 also I have covered DC generator, DC motors, and speed control of DC motors full. So from here also 40 marks will be asked, but you have to write only 20 marks full question. So from this 20 marks you can write it conveniently. So 60 marks is over. So unit 4, losses and efficiency and testing of DC machine, full unit I have covered. So this so here also 40 marks will be asked, and you have to write only 20 marks from here. That means from full question. So this also I have covered. So 80 marks is over. Now from unit 5 also, from here it is 20 marks, and here it is from 20 marks. So total 40 marks will be asked, and here again you have to write 20 marks, and the 20 marks already I have covered. So totally 100 marks I have covered in this DCMT subject. Still that one particular portion, like this cord connection, I guess this cord connection I have not taken. This cord connection I will take it tomorrow. I will take it and I will finish it off. So with this 100 marks I have covered this particular chapter. I'm leaving it to you, but within March, if I get time, so I will go through this welding transformer as well as tap changing transformer. So 2 transformers I will cover from this chapter also if time permits. But as of now, the DC machine subject 100 marks is covered. Not only 100 marks, actually 140 marks is covered. This 20 marks is not covered. So out of 140 you can write 100 marks very easily. Here there is an option, this option only I am leaving it to you, but rest all I have covered. So 100 marks is covered conveniently. So tomorrow I will take that squad connection and I will finish it. This is what the plan, what I have. In future, in the February or before March, if I get time, I will cover these 2 concepts also. Is it clear?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so what you can do now, so I have prepared the notes of that special electrical machine 1, that 20 marks notes I have prepared. So today or tomorrow I will scan it and I will upload it in the Google Classroom. With that notes, 100 marks notes also I have given it to you. My own notes, not somebody else I have taken. It's my own notes. I have given it to you, 100 marks. That is also covered. So that special electrical machine 2, that notes I will not prepare. Next year I will prepare for next batches. This is the first time what I have handled, and for this time, as even I have a lot of work, but still I have done my thing and tried to complete within the time. Yes, recently I did not get much time, and due to some IA, some extra things. So I have not conducted the class, but I have whatever things I have covered it conveniently. This last chapter I am giving it to you. Next week, next Wednesday and Thursday, we'll conduct the presentation. So for every batch, maximum 8 minutes will be given, or 6 minutes will be given. Within 6 or 8 minutes, all 4 of you have to present your seminar. You plan accordingly and present your seminar topic. So Wednesday and Thursday I will finish that also. With that, your all CIE components will get over. So then from next week onwards, there is no need to attend any classes of DCMT and all. But February last week, if I get time, I will intimate in the WhatsApp group, so that I will take some 2 classes for that special electrical machine 2. Then that you can attend during that time. Clear? Is it clear?
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay.
Yes, sir.
Now you can take some 20 minutes time, or 20 minutes time, and 11 o'clock will join. Otherwise, shall I continue and finish at 11 o'clock?
Okay, sir.
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir.
Because that servo motor is very small concept, which I don't want to cover in lengthwise. So within 10-15 minutes, I will cover. I will tell you what exactly it is, and I will finish it off. Is it okay?
Yes,
Yes,
sir.
Yes, sir.
Okay, fine. Okay, servo motor. Now, servo motor. When we are calling servo motor, what things will come into mind is This is a motor, special motor. Okay, but this is not a special motor. It is a class actually. It is a different class. Servo motor, if you go and ask in the particular shops or in the manufacturers, so that a servo motor does not exist actually. It is a class. So it is a system. It is a servo mechanism system. It is a servo mechanism system. Basically, there are two types of servo motors. One is a AC servo motor, and DC servo motor. DC servo motor. And it is based on the supply what you give. Based on the supply what you give, it is a AC servo motor and DC servo motor. And based on the motion, it is a rotary actuator servo motor. Actuator servo motor. Then linear actuator servo motor. Linear actuator servo motor. This is based on the rotation, or it is based on the motion. Based on the motion, it is rotary actuator servo motor, and based on the motion, it is linear actuator servo motor. And based on the supply, it is a AC servo motor, and based on the supply here, it is DC servo motor. In this way, it is classified. Here, servo motor means basically it like same like a DC motor only, normal DC motor. It is basically same like a AC motors only. But then also they are calling DC servo motor and AC servo motor because the mechanism what they are using it, that makes it different. Otherwise, motor wise it remains same. You can use your normal stepper motor only, okay, or you can use normal your DC motors only, or you can use your normal brushless DC motor only. You can use these motors, okay. And to this you connect the system, you connect one system, and that system itself is nothing but servo system. And then this motor is called servo motor. Then this motor is called servo motor. That's it. So there is a servo mechanism is there, and a servo mechanism is connected to the particular motor, and then that motor is called servo motor. That is what the difference. There is no particular servo motor. The particular one motor can be used as a servo motor. If you use that system along with that motor, then it is called servo motor. Clear? What exactly servo motor? Servo motor does not exist. It is a class. It is a system. If you use existing motor with that servo mechanism, then it is called servo motor. That's it. Now, if you use AC motor and along with that mechanism, then it is called servo motor, AC servo motor. If you use the DC motor along with that servo mechanism, then it is called DC servo motor. That's it. Then, that based on the motion, this motor can rotate in this angular fashion. Then it is called a rotary servo motor. If this motor moves straight and again comes back, then it is called linear. That's it. So based on the motion, if it is moving linearly, then it is called linear actuator servo motor. If it is rotating in the regular normal rotation, then it is called rotary actuator servo motor. Now, why servo motor is required? So why servo motor we prepare? Only the thing is, last class only told, modification of stepper motor is nothing but servo motor. So here, very precise position control. That also for that same thing, but there were feedback system was not there. So because of that, sometimes it misses the desired or objectives. But here it will not happen. Precise position control and precise speed control, and it has very high static holding torque, high static holding torque. These things will be available in the servo mechanism motors, servo motor. Hence, this motor will be prepared. Now, precise position control means what? For example, there is a one object. This object has to be moved exactly 5 centimeter, and this object weight is around some 5 kg. And this 5 kg object should move exactly 5 centimeter here, and it has to be placed here. So then we use servo motor to hold that particular object, and exactly precisely it moves 5 centimeter and it keeps that object there. You might have seen in the packaging industries, or you may have seen in the automobiles. In the automobiles for repairing and all, some robots will take that glass up and it holds there, and another robot will come and it which does the work, and again it takes back and places the that particular glass there, or some doors, windows, like something like that, it does the work. So at the same time, antennas in the satellites, exactly particular this much degree has to be rotated, so that will happen. So that will be help with the help of servo motor. In the robots, whatever arm control, that arm has to be moved only 12 degree, 13 degree, and exactly it has to stay there, and that can be done with the help of servo motor. So that is what precise position control, at the same time precise speed control can be done with the help of servo motor. And what is very high static holding torque? Because as you all know, motors, general motors or normal motors, what it does, if it starts rotating, it rotates. That is easy thing, it can done. But here, this servo motor, what it does, it holds some object, and now it lift 30 degree, and it take that particular object and put here exactly there only. So it stay there only, collect the object and move, and in that position only it will stay with that particular weight, that holding that particular object and staying there. That is called static holding torque. That makes the difference with the normal motor. Normal motor, it goes on rotating, but it will not rotate, it will hold that particular object, and it holds in the particular direction also at particular angle. That is called static holding torque. That makes this motor different. So now stepper motor also does the same thing, but sometimes that variation may happens 95% it does its work. Somewhat in some 5% or some 1% it may not do that its work, maybe because of a lack of signal or lack of that pulses, etc. So that time it will not does that particular work correctly. Hence, to avoid that condition, they have come up with a servo motor which will not miss the signals itself. So that exactly whatever you decide, that particular thing will happen at correct time with the correct measurement. So hence servo motor will be used. So that is what I said here. This particular object should be hold and it should be moved here. So 5 kg and this much centimeter. So based on this, normal motors we rating will talk with in terms of HP or in terms of kilowatt we talk. In shop we can go and we can tell that 10 HP motor you can give me, or something like that 1 kilowatt motor you can give it to me, like that we can talk, we can ask. But if when you are going for servo motor, then we cannot use this HP and kilowatt, we cannot use. What we have to use is kg per centimeter we have to talk. So they will ask how much kg you want to do. So that time normal available motors are 3 kg per centimeter, some 6 kg per centimeter, like 12 kg per centimeter, or some 50 kg per centimeter, like that. In this way rating it will be available. So 3 kg per centimeter, what it means, a particular motor can hold, or it can hold, or you can carry that 3 kg per centimeter, it can move that. So in that way you will get the motors rating of the servo motors. So I hope what is a servo motor and for what purpose we use that you know. Construction wise, if you come to the things, the motor things remain same. If you use AC motor, that AC motor construction remains same. That DC motor, if you use that DC motor construction remains same. There is nothing change. The mechanism or system changes. That system will see servo motor system. So in the examination also, if they ask servo motor system, there is no need to draw the diagram of servo motor. This system you have to draw. So in this servo motor mechanism system, what all things it consists? Basically, there is a controller, and this controller gives the input to the motor, and this motor is connected to the gearbox, and here that output we are going to get. Now this from the gearbox it will be given to the encoder or it to the potentiometer. Then this will be given to this as a controller as a feedback, and this controller what it gets, it is the input. So the input will come to the controller, and controller will decide that I need to give the signal to the motor. So motor gets the signal, and once the motor gets signal, motor starts rotating. This gearbox is used to reduce the speed, speed accordingly, or accordingly you can increase the speed based on the requirement or application. This reduced gearbox will be used. So accordingly this output, that means this shaft rotates. If for example input signal will be given in terms of pulses, that means pulse width modulation signal will be given to the controller. For example, we want to rotate 60-degree. Now, for to rotate that 60-degree, what is the pulse width that will be decided, and it will be means we will be given to the controller. Controller decides that for 60-degree this much signal will be given. That 60 for degree that pulse will be given to the motor, and motor will get the signal and it will get energized, and gearbox accordingly changes the speed and it attains the 60-degree rotation. Once the 60-degree rotation is achieved, then that signal will goes to the encoder or potentiometer. So encoder and potentiometer sense that signal that it is reached 60-degree, and this signal will be given to the controller. So controller controller gets that it is reached 60-degree, then it stops the signal. Then it will not get energized, so motor will be in that condition. Again, if you want to rotate, so otherwise if it has, instead of 60-degree, if it has moved 30-degree, so then it senses the 30-degree, and 30-degree will be given to the controller. So controller come to know that only 30-degree has moved, so accordingly it will change the pulses, and one more pulse will be given to reach the 30-degree. So 30-degree will go, and it will makes the 30-degree rotation. Another 30-degree rotation, it makes 60-degree. So again it goes to the controller. So then controller senses and accordingly it works. So here the difference between the stepper motor and servo motor is, the only thing is this feedback. So feedback is available in the servo motor, but in the stepper motor it is an open loop system. Open loop system, hence it is a simple and cheap also. But accuracy is less here. Accuracy is a little bit less comparing with the servo motor. But servo motor, it is a closed loop system. It has the feedback. It is not simple, little bit complex and a bit costly comparing with the stepper motor, but it gets high accuracy. It gets the high accuracy, and for this high accuracy only this servo motor system will be used. That is what the main difference between the servo motor and the stepper motor system. Otherwise the rest all things almost remain same, and applications also remains same. You can use that stepper motor also at this particular application, but if you want very high degree of accuracy, then you should go for the servo motor system. Hence nowadays in all the industries they use servo motors only for their works. So this is what about their servo motor system, and with the help of this servo motor system, I will conclude the first chapter of the last unit. So if you have any doubts, you can ask me. Otherwise, we'll wind up. Is it clear?
Yes, sir.
So from this chapter, what type of questions will be asked? That 10 marks question will be asked like that. Explain with neat diagram stepper motor and mention its advantages, disadvantages and applications like that. For you have to draw the diagrams and construction you have to write, working you have to write, then afterwards applications, advantages, disadvantages. So 10 marks will be asked. In the similar way for brushless DC motor, similar thing for the permanent magnet DC motor, similar thing for the servo motor also. So in this way, the question will be asked straightforward. There is no much means a twist will be there. So normal straight questions. So straightforward answer, you have to write it accordingly for 10 marks. That's it. So it is very easy chapter to earn 20 marks. Clear?
Yes, sir.
Yes, sir.
Okay. With
Yes,
this,
sir.
I have covered 100 marks of syllabus to you people. But still, that very small that one question may come of squad connection of 6 marks or for 7 marks, that I will cover in the tomorrow class. Fine. So that I will cover it and I will wind up the this GCMT classes in the month of February end or March first week. If I get 1-2 classes, then I will take those 2 classes for the special electrical machine 2. Till that you can go through that special electrical machine 2 on your own also. But now if somebody asks you about the DCMT subject, so that you can say that 100 marks portion is covered, so syllabus is over, you can say it. Clear?
Yes, sir.
Yes, sir.
Okay, and at the same time, about presentation, I have already told 6 to 8 minutes you will get. Accordingly, your batch, you student, you just decide how to give and all those things. Wednesday and Thursday will finish it off. Now I will give to everyone 20 marks. To everyone I will give 20 marks out of 20. But based on your presentation, that 20 marks goes on reducing. So be prepared, prepare nicely within available time, 1 minute or 2 minutes. Try to give a good seminar. That means that presentation, what you present it properly. That's it. Fine.
Yes, sir.
Yes,
Okay.
sir.
Okay.